All right, so I'm going to work problems from the sheet. This is the first one. I kind of gave you a real simple one to get your feet wet. So we're going to remember that we always want to pick according to length. So that was logarithm, algebraic, trig. Never pick exponent. Never, ever, ever. It's not going to take you anywhere nice. So for the u, I see a log. Yay! That's my choice for u. And for my dv, everything that's left over. Now, you're supposed to write them properly. I know some people won't write the dx there. I mean, you should. It's a derivative, right? If dv stands for derivative of v. So you're going to take the derivative of u, which is nice and easy to do. It's 1 over x. And remember the dx. If you forget, it's not the end of the world. Now you're going to find the antiderivative. So you're integrating this, which means I'm going to add 1 to the power, flip that power over, put it in the front. That 1 over 4 eats up that 4. So you just get x to the 4. Right? Little side work. Real quick. Do it in your head. You don't got to write it down. I'm just writing it down for you. So the nice thing about the formula, because it's u times v minus the integral of v du. So, as I said in class, you just go across here. Well, my red marker decided to run out of ink. Do I have another color? I could use green or blue. I use blue. I like to use another color. So, very sad. So you go uv. So times them together. Remember, put this in the front, because if you don't do that, you might write ln x times x4 and then make this x5, and then you're completely screwed. You're not going to make that mistake if you write it like this. So when I do uv, I always like to write this in front of the logarithm. It's not wrong if you don't, but you want to resist temptation of doing weird shit. So uv and then v du. So you go diagonally and then you go straight across. So minus the integral of v du. So v is that, du. This is why the dx is supposed to be there, right? I mean, this is an integral. This is an antiderivative. It's supposed to have a dx here. That's why you should put the dx here, right? The dx goes away here because you're finding an antiderivative. You're integrating, so the dx goes away. Here you're taking a derivative, so the dx goes there. That's why these are really complicated, because within the question, you're doing a derivative and an antiderivative to plug into the formula correct. So it can be really tricky, and it's very easy to make silly little mistakes. Before you integrate that, you have to make sure that you simplify it. So that's what I'm going to do. I have x to the 4. Now, 1 over x, right? It looks like that. That's x to the 1. Subtract the exponents, right? x4, take away. 4 take away 1 is 3. That's it. Now all I have to do is integrate that. So my uv is always there. You don't got to do nothing with that. That's what's awesome about the formula. The whole purpose of this is to create something here that integrates nicely for you. That's the whole technique. That's what integration by parts does. It gives you this for free. This one you have to find it. You start with something you cannot possibly integrate. Cannot find an antiderivative of this. So you create a simpler one for you to integrate throughout the problem. So I'm going to add 1, divide, right? Add 1 to the power, you get x4. Flip that over, throw it in the front, or whatever. I know people still divide. It's the same thing. So there you go. And again, the first one is always the easiest one. So I'm going to do some more. All right, so this is number 2. And again, a little more complicated. So now our good buddy ln is not there. Natural log's missing, so sad. So again, I'll use my acronym of late. Log is missing, but I do have an algebraic thing. There's a letter. If it's got an x, algebraic. And then a trig thing. Algebraic beats the trig. So we're going to pick that to be the u. So my u is going to be 5x. That means my dv is everything that's left over. And, put it all there, right? Once that's u, everything left over is the dv. Now play the game. Take the derivative of u, which is 5 dx. You can just write 5. I'm not going to have a heart attack, although I'll end up writing it for you. So v, you're going to antiderivative this. Now be careful, right? Remember, you're integrating now. I will see people just put cosine here. The derivative of sine is cosine, but you're not taking a derivative. You're doing an antiderivative, right? This dv is the derivative. That's why the dx is there. So remember, the derivative of cosine is negative sine. And I don't have a negative there. So you got to put a negative there. Okay? So this is going to be super, super careful. I always like to write it. uv minus the integral of v du. So again, diagonally, UV. This is why, please, 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 if you're in my class and watching this, you might not be in my class and watching this, but if you're in my class and you're watching this and you set up your integration by parts for me, please don't just write this in one big line across. Please set it up the way this is how they do it. This is how they do it in the textbooks. This is how everybody sets it up. They always put UDV and then the V underneath and the DU underneath. It just makes it harder for me to grade if you don't do that. Like if you just write it all across in one big line like that, it's a disaster. So UV, now again, be careful. I want to put this in the front of that. So you don't want to write this down. Now some people will just say, but I could put parentheses here. First of all, without the parentheses, it means 5x take away cosine x, right? This is 5x minus cos x. So even if you put the parentheses, it just looks stupid. Just write it like this. Please, right? That's all I want. So that's going to be my UV. So I'm going to put negative 5x times cos x. I am done. That's it. That's all I'll ever have to do with that. Minus the integral of v du, right? So straight across here. So again, put the 5. Now, you have a negative there, so you got to be very careful with this. I'm going to put the negative here. I'm going to put 5 cos x dx. See, dx is here. Put it there. Now, you can do this very simple. When I'm doing this problem, I see this negative and I see this negative. Remember, you can always take a constant out into the front of the integral symbol. So I'm going to do exactly that so I don't have to get stuck with a minus sign that I get confused about. This negative will eat that negative and make a plus, right? 2 wrongs make a right. Now I don't have to worry about the 5, and I'm not going to. All right, so I pull that minus out with that one and make a plus. Now I just have a really basic, right? So pretend that none of that's there. This is like day 1, antiderivative. Whose derivative, right? You started with a guy, you took his derivative, you got cosine. Positive cosine. That's why you don't want to put the negative there. You'll get confused. So it's just sine. It's 5 sine. The derivative of 5 sine is 5 cosine. So very, very simple. We now have a plus there. And the integral, if I could write my n correctly, n plus c, don't forget the plus c. So then you make sure, derivative of sine, cosine. No sign switch. I already did my sign switch here to take care of it. So that's it. These integrals are always kind of nasty. They're long. You can check them very easily. Like I showed you in class. You can do first derivative second, second derivative first, and then that derivative. And if you do it, you get there. You can check yourself. I'm not going to check it here in the video because it's a waste of time. So I'm going to do another one. Okay, so number 3 is the first one where they start to get a little bit more complex. So I have a letter, 1x, and I have an e. So again, I have no log. I do have algebraic, and I do have exponential. Algebraic always wins over that. So my u is going to be 1x. And I'm just writing that for emphasis. You don't have to put the 1, but I am. The dv is everything left over. This is where I talked about this in the little lesson video. Integrating that's not trivial. We'll get to it in a second. First, I'm going to do my very easy derivative of x. Derivative of x is 1 dx. Do you have to write the 1? No, you don't have to write the 1. You can just write dx down. But I like to write the 1 for emphasis, to know that it's there, right? That's what's in front of an x, the 1. Now, when you go this direction, again, it's really important that you recognize integrating e to the x is trivial. It's e to the x, right? The derivative of e to the x is e to the x. But the derivative of e to the 3x is not e to the 3x. It's e to the 3x times 3. So there should be a 3 here, or there, but there's not. So you have to, remember what I said you're going to do. You're going to take 1/3, whatever that number is, you just flip it over and put it in the front. And there you go. Okay, now you can check. Take this derivative with the chain rule and make sure it matches this. You have the ability to do that. Just take out a piece, use your scrap paper or your notebook, whatever, and just, if you're not sure you did this right, take that derivative, right? It's e to the u times du. You can check in 2 seconds if you did it right and make sure it matched there. There might be another number there. There might have been a 6 here, right? You have to, so you're doing that u substitution without doing it because really you have all this other stuff to do. You don't want to be sitting here doing u substitutions off to the side. You can if you really feel like you need to, but I don't think it's necessary. So again, it's uv minus the integral of v du. So you're going to do u times v. Now again, I like the letter to always be in the front of whatever's there. So I'm going to have 1/3 x times e to the 3x, right? 1/3 and x, and then e to the 3x. That's my uv diagonal. Now I'm going to go straight across. I'm going to do v du. There's nothing to do here. Just tack on a dx. You have 1/3 e3x dx, right? Times 1. Ooh, that changed it. No, it didn't. Times by 1, nothing happened. So now once again, chain rule, reverse, right? I started with something, took its derivative, and got that, right? I have to get this 1/3. So you're going to do the same thing. You're going to take what that power is, you're going to flip it over, put it in the front with the 1/3 that's there, right? Take 3, flip it over. That gives you 1/3. You already have a 1/3. So now you're going to get 1/9. Some of you like to do silly stuff. I've seen 1/6 there. It's a shame. It happens. But that's it. So you have the 1/3 x, e3x. That's my uv. This was my integral. Look, you could not take the antiderivative of this because of the x. This you can. See how you got something more basic here? This is simpler than what you started with. This, I can just, boop, do the antiderivative. It's a little tricky because of the numbers, but that's where you have to do the offset, right, of the u substitution without doing the u substitution. Like I said, if you really feel like you want to do it off to the side, you could absolutely do that. You could do that. You could say u is 3x, du is 3. You could play the game and then e to du. Like, you could do it, but I wouldn't do it. You don't need to. I'm gonna do another one. Okay, so 4 again. A little more complicated. Chain rule or u substitution, however you think of it. I like to think of it as chain rule because it is a chain rule. So again, you have an algebraic thing, something with a letter, and you have a trig thing this time. Algebraic still beats that. So my u has to be the algebraic thing. My dv is whatever is left over, and you write whatever is left over exactly as you see it. That's left over. That's the u. So now I'm going to do the du because I'm taking a derivative is way easier. So I'm just going to get 2 dx, right? The derivative of 2x is 2. The x goes away, right? Multiply by the power, subtract 1. So basic calc 1. Now again, this is complicated to find an antiderivative of. If it was just this, oh, I mean, I'm so stupid, I wrote the same thing. If it was just this, right, the antiderivative, the integral of cosine would just be sine, right? Because if you take the derivative of sine, you get cosine. So, but I have a 4 there, so it's not as simple. So what I told you to do is take that 4, flip it over, put it in the front, and now you're going to put sine, and the angle doesn't change, right? If you see 4x, that 4x is forever. The angle that is attached to the trig function cannot be altered, whatever it is. 2x, 3x, x squared does not change, right? Does not change. So but it's always going to be a constant. It's going to be like a 2, a 3, a 4. So, but check real quick. I'm going to check. I want to make sure that I integrated correctly. The derivative of sine u is cosine u times du. You can put it there if you like. And see, that 4 eats that 4, and you get that. I always write the 4 in the front, but some students don't. So the d, I always put the du in the front, so I know that it works. So now again, I'm going to do uv minus the integral v du. So it's going to be uv. Now you got to be careful here. I have 2x, 1/4. So do this smart, right? You got to simplify this. That makes 1/2 x. So sine 4x. Be careful, right? It's not sine x, it's sine 4x. This never changes. This is your u in the du thing. This never changes, right? If it was chain rule. So uv, I took 1/4 of 2, which gives me a half, right? Just divide the 2 into the 4, get a half. The x goes along, the sine 4x goes along. Minus integral. Now you gotta be careful again. You're gonna go this way. First you go diagonal, then you go across. So it's v du. Now look, you have 2 and you have a 4th. That's what I just did. 2 into 4. So you get a half there. So you get a half sine 4x dx. Dx is supposed to be there. It's an integral, right? Find an antiderivative. Got to have a dx on the integral. This is never changing now. That is part of your answer, and it's not going anywhere. So that's going to stay. I like to put my little dot between them. So now, again, you got to be careful. You're integrating, finding an antiderivative, but chain rule, right? This is a reverse chain rule. It's a U substitution. So I told you, take this number, flip it over. You already have a half there. So you're going to do that, and then you're going to do 1 over 4. So that's going to give you 1 over 8. Now, you know the derivative of cosine is negative sine, but there's a negative there, so you have to be very careful with this. This is why I'm really careful. So it's going to be negative cos 4x plus c. Hope you see what's going to happen. All right, you can check it. The derivative of cosine, the derivative of cosine is negative sine. So I need this negative there. But the same thing is going to happen. This negative and this negative are going to eat each other up and make a plus. So you're going to get plus 1 over 8 cos 4x plus c. And then my uv is still there. 1/2 x times sine 4x. Right? This one is a lot more complicated. It gets to be a real headache when you have things there that are not x. Like the first two examples were very straightforward. Right? I mean, you had ln x, you had whatever the hell it was, sine x. So they get more complicated when there's different things, when it's e to the u or sine or cosine of u. So you got to be very careful watching, because it's not going to work if you don't have this there, right? You have a 1/8 there. Eventually, you're going to times that by a 4, right? When you do the chain rule, you'd be timesing this by 4, so you'd have 4 over 8, which is a half. Then here, you're going to take that and you're going to multiply it by 4, right? And 4 over 2 is 2, right? It always has to get you back to where you started. You could always just keep taking derivatives, right? You found antiderivatives. But if you just take the derivatives and work your way backwards, you should end up with the same number that's there. So it's easy to check, right? 4 over 8, half. And then do it again. 4 over 2, 2. So, you know it worked. It doesn't work if you don't put those numbers there. All right, so I'm going to do 5, and then I'm going to make another video for the really hard ones. Okay, so this is number 5. My head's in the way. Now, you see ln, our good buddy, log, yay, but then it's not ln x, so boo, it's a little more complicated. But it doesn't matter what's with it. As soon as you see your buddy natural log, you should be very, very happy. This is always your choice of u. Whatever is left over, right? You pull him out as the u. Whatever's left over is the dv. Just write it carefully. Now, I'm going to take the derivative of u. So remember, this is chain rule. If you take the derivative of the natural log, it is du over u. And there's some students, no, my professor said 1 over u times du. It's the same damn thing. Du goes on the top of this fraction. It's stupid. This is the less moron way to do it, okay? So you're going to put the u, which is x4, on the bottom. You're going to put his derivative above it, which is 4x to the third. You cannot leave it like this. You must simplify it. You have 3 x's upstairs, right? You have 4 downstairs. Do this like you're in the 3rd grade, right? Boop, boop, boop. 1x left over on, right? Those cross out. You're left with 1x downstairs. 4 is upstairs, right? You got to simplify it. Don't forget your dx. You took the derivative. All right, so, a little bit of work there. You screw this part up. I want you to think very carefully about this, right? You're doing uv and then v du. If you mess up the du, your integral is going to be all wrong. So it's very important you don't mess this up. You have to be careful. Now, this is really easy, but again, you could mess it up. You're integrating, right? That's what I'm telling you, dv. dv means you're going to integrate. So you're going to add 1 to the power, and then you're going to divide by that power. Or if you like, flip it over, same thing. So you get 4 x squared, right? The power, you add 1, power becomes 2, divide by that, 8 divided by 2 is 4. So, we don't have to do too much with this. So now again, I'm going to do uv minus integral v du. Please write it. It helps. Why not? I mean, it's there, and then you just you see it visually really nice. So it helps to write it. So I'm going to do uv. Now, as I said before, given a choice between writing it like this and writing it with this in front, I will always put the algebraic, the x's, in the front of the natural log. This just looks wrong. And also, I have seen people times them together. So to avoid the temptation, when you do the uv, put this in the front, please, just for you. So it looks nice. That's UV. That's done. I'll never have to deal with it again. Minus the integral of V du. So you put the V first. Then you put the du next. Now you got to be very careful, right? It's 4 over x dx. Not that bad. Now I'm going to neaten that up, and then I'm going to integrate. So, not this isn't a super difficult one. Any problem with ln is going to be very nice. These integrals come out super good. So I have 4 times 4. That's 16. I have x2 on the top, and I have x on the bottom. That gives me x1, right? Again, 4th grade. Should be doing that stuff, maybe 5th grade. So again, my UV never changes. You're always just carrying this along for the ride. Once you get that part, good to go. Here you're going to get something basic to integrate. You're not going to get anything easier than this, right? You're going to add 1 to the power, which makes x squared. And I like to flip that over, put it in front, whatever. Or if you want to just put it underneath, you can put it underneath, whatever makes you happy here, because they're all whole numbers. It's easy to do. So you get 8. So you get minus 8x squared plus c. Very simple. Right? That is the antiderivative using integration by parts. Okay, so once you get to number 6, they start to get hard, right? Then there's situations where you have to integrate by parts twice. Do I really want to do it? I don't, because they're long, time consuming, but that's why I'm going to put it in another video. I will try to do 6 and 7 and show you how really complicated that these can get, because I've done it seemed that they were a little complicated. But of the integration techniques, it's not the worst one. They get bad. All right, so hopefully this helped.